All right, thank you for tuning in today. And today we're talking about Wi-Fi 6E and extending Wi-Fi to 6 gigahertz. Excited, we've got a great panel for you today. We've got Bob Friday, Dean Bubley, and Jussi Kivenemi. So with that, I'll let you guys introduce yourselves.
Yeah, thank you, Christian. Yeah, Bob Friday. My history in wireless started back in the old Metcom Ricochet days with Mesh. Went off and built Airspace, which is the old controller transfer. And then from my Cisco experience, started Mist. And we're here today to talk about 6 gigahertz and the evolution of Wi-Fi.
Hi, I'm Dean Bubley, also Disruptive Dean on Twitter. I'm an industry analyst and advisor, and I've been covering various aspects of wireless and telecoms and networks for longer than I want to think about. I'm usually one of the sort of grumpy old men of the analyst community, I think it's probably fair to say.
Hi everybody, I'm Jussi, almost as grumpy as Dean, been in the industry also for way too long. Been with Wi-Fi for like 20 years and mostly focusing on location tracking, indoor location tracking, as well as especially Wi-Fi and RF design side of things. And today work at Mist as a global technologist, which essentially means I'm a janitor.
All right, and let's jump into that. I mean, one of the first things you notice is just there's a lot of 6s going on. Wi-Fi 6 came out. We've got Wi-Fi 6E, which I get a lot of questions about. What is that? And then 6 gigahertz, which is what we're really talking about today, which is extending Wi-Fi, which was primarily before 2.4 and 5 gig spectrum, to now go into the 6 gig range. So Wi-Fi 6E is also from the Wi-Fi Alliance, like Wi-Fi 6, and is really focused on now extending it into the 6 gig range. So a little bit about spectrum policy. I mean, what's going on in terms of the industry here, guys?
Yeah, no, I was just going to say that Wi-Fi has pretty much had the same bands for spectrum for many, many years and haven't had new allocations to expand capacity significantly for a while. And at the same time, you see in the cellular industry, there's always being more new bands added for what was 4G, now 5G. And so it's probably the demand for Wi-Fi use in homes, in businesses, public spaces has grown to the point where there's definitely pent-up requirement for more spectrum. And then the question comes in as to exactly how much and where. Bob, do you want to jump in?
Yeah, I mean, I think from my perspective here, Christian, if you look at the invention of radio, the governments have been trying to regulate spectrum, which is this a pure natural resource, since the 1930s when the FCC was created. And back in the 1930s, they had no vision of the mobile internet, right? And so now we're kind of in a phase where we're basically 70% of our traffic wants to be mobile right now. And so inherently, the regulators around the world are struggling with how they deal with this legacy problem, right? That they've basically given out the spectrum to a whole bunch of different entities out there in space. And so right now, they really are challenged with, how do they actually start to share the spectrum, because they can't clear it out anymore, right? They can't just remove all these uses, right? We got military, satellite users, fixed point-to-point users. So really, if you look what the regulators are up to, and it really started in the 1980s when they really released this unlicensed spectrum, right? And that was really the beginnings of a new paradigm of sharing spectrum. So I think right now what we're seeing is the demand for mobility. We're seeing the government regulators basically try to come up with creative ways of how to make spectrum more available to really the demand of society wanting to go mobile.
Now, I mean, I saw FCC, there was some news in the past couple of weeks here. Can you weigh in on that, Bob? I mean, what was it all about?
Yeah, I mean, this has really been, I would say this is on par with the early 1980s when the FCC first released these unlicensed spectrum. Really what we saw is the FCC chairman basically announced the proposal of new rules for almost doubling, tripling our unlicensed spectrum, right? So this is basically allowing us to start to bring all the benefits of .11ax and Wi-Fi 6 into a new band. And when you look at Wi-Fi 6, really the big value of that was these big channels, right? As we get into these higher speed, basically Wi-Fi 6 brought these 160 megahertz channels. and we really weren't able to utilize those, right? In the 5 gigahertz band, there's like one channel if you were lucky to use like. So really, we're basically FCC is opening up almost 1.2 gigahertz of spectrum for really the next generation of mobile use cases, right? Any use cases that really require high speed, low latency is what the FCC is enabling for us.
Yeah, now, I mean, there is existing stuff happening in these channels today. How are they getting around that and opening it up for unlicensed? I mean, is it just restricting where it's used, the power?
And I'll take a first shot at that. It's something that's happening all around the world. What we've got is a lot of bits of spectrum that are fairly lightly used. They're just used for point-to-point links in certain places, maybe satellite uplinks, maybe government or military spectrum used in certain places at certain times. And so given, if you like, there's no new spectrum being created, there's a lot of approaches to come up with creative ways of allowing spectrum to be shared or reused at certain places in certain times. And there's a number of technical ways of doing that, of essentially having a database or a lookup function or some sort of protocol to check to see if a given section of spectrum is being used locally. And what's being looked at for this band, certainly in the US, is to allow low power use on a purely unlicensed basis indoors. Because, I mean, if it's low enough power, then frankly, there's not going to be any interference with, I don't know, utility or a broadcast connection. And then outdoors, there's going to be a database function called an AFC, I think, automatic frequency controller, which essentially is the something which will allow you, with an internet connection, the access point to determine whether it's allowed to use 6 gigahertz or what part of the band at a given time in a given place. The US is slightly different to what's likely to happen in other countries. So at the moment, the US is looking at taking this whole 1200 megahertz block, but the whole 6 gigahertz and a little bit on either side, subject to any final changes in the next iteration of the rules. In Europe, it's looking like they're going to divide this into 2 chunks, a lower half and an upper half. The lower half is probably going to use something similar, where again it's going to be unlicensed at low powers indoors and perhaps very low power outdoors, but that's still to be confirmed. And then the upper band elsewhere in the world is perhaps going to be dedicated for licensed use like 5G, but there's a lot of politics there. China in particular would love for the whole thing to be dedicated for 5G or licensed use rather than Wi-Fi. So I think what we might end up with is the US going all unlicensed, China going all licensed, and Europe being somewhere in the middle.
Okay, so I mean, the net of it is, I mean, with all the spectrum, I mean, you talked to it a little bit, Bob, in terms of now supporting wider channels, which, I mean, people were talking about it for years in the 5 gig, but reality was, yes, for the home, I could do one channel, but in a real enterprise, you just couldn't take advantage of it. So how is it going to impact design? And I'm going to throw this to you, UC, because you've done a lot of work in terms of designing large networks. What is the impact here? Are we going to see, in terms of, we see more APs deployed, higher densities? I mean, what's the net of it?
I think there's going to be a couple of things. If we look at it from the beginning, 2.4 gigahertz, that was like kind of where it all started. And today people are proclaiming that, they're saying that 2.4 gigahertz is dead because it's so crowded, like all the IoT devices that operate on Wi-Fi, or most of them, the vast majority of them are on 2.4. So 2.4, because of that and because of Bluetooth and a few other things, it's getting very, very crowded. Now, same thing was happening to 5 gigahertz. So it's this is also like the foundation it's a survival mechanism for Wi-Fi. Like there's so much more added traffic and added users all the time. Something new had to happen. But in addition to that, I think the added benefit and design aspects it's gonna be two schools of thought here. Some are gonna utilize the full 160 megahertz channels, and there's actually plenty of them as well, as it's looking like right now, for even for the enterprise use. But then there's the other alternative of using narrower channels and just using more access points and maybe a little bit more like relaxed AP placement. So previously, Wi-Fi has had this problem of co-channel interference, even on 5 gigahertz, especially because of DFS radar and radar backoff and all that kind of stuff. So with that limitation like almost gone, those that have the big bucks and can invest a lot in a Wi-Fi network maybe can be a bit more relaxed on the Wi-Fi design side of things if they don't, value getting most out of their network on a certain budget. But then again, Wi-Fi 6E will definitely not change the fact that to get the maximal performance out of your network, you have to think about the channeling and the channel widths and still do a proper design for both coverage and capacity.
I'll throw this one over to you, Bob. I mean, how do you think this is going to impact things like channel planning and radio resource management? I mean, it sounds like it's going to get more complicated because now you're going to be able to see more channels available. And can you sort of weigh in on what's the impact there and how can customers and vendors look at improving that?
Yeah, I mean, for those who know me now, I'm a big AI ML fan. I mean, I think as we start to see more of these 5 gigahertz, 6 gigahertz channels come in, I think RRM is going to become even more important. It's going to get to the point where it's going to be beyond someone be able to manually set all the knobs right now, right? Because we're going to have band steering knobs now. We're going to have channel width knobs. There's going to be so many knobs available. It's going to be hard for a single individual to kind of sort out the optimum solution for how do you basically set all the knobs in your network for the applications you want. So from my perspective, I think what we're going to see is this radio resource management is going to start leveraging new algorithms to really solve an optimization problem that we're going to be facing with all the different levers we have available to us.
And just to add to Bob's comment, there's an additional layer of complexity here. Whereas many of today's devices support both 2.4 and 5 GHz bands, now there will be a mixed variety of client devices, like some of them 2.4 only, which are kind of fading out these days. But then there will be devices, most of the devices for a long time will be 2.4 and 5 GHz compatible, and then there will be some that are 2, 4, 5, and 6, or maybe only 6, or maybe only 5. So that also puts more importance on the RRM. Not only does it need to make a good network, but it needs to make a good network for all of the client devices that you have in your network.
So, Dean, what are you seeing in terms of it sounds like we're going to need new clients, new chipsets. I mean, what do you think is going to happen here in terms of sort of the evolution of it?
Well, I think the first thing that's worth pointing out is that one of the nice things about 6 gigahertz is that it's, if you like, completely clean spectrum. So it will only be Wi-Fi 6 in 6 gigahertz. There won't be earlier versions of Wi-Fi using this new band, which then allows you to use all of the new features of Wi-Fi 6 in OFDMA, and that allows with approaches to delivering quality of service and different classes of device. Now, in terms of when and how we start to see silicon and devices, it looks as if depending on what happens to the regulatory process, given the pandemic at the moment, we should be starting to get 6 gigahertz in North America, products starting to ship towards the end of the year, maybe in the UK, which looks as if it's slightly ahead of the rest of Europe, but it's a little bit hard to call exactly when all of the legal and regulatory side gets signed off, given a lot of regulators now also working from home and are either slowing down or delaying some of their work. What I would expect is that we've certainly seen announcements from at least one of the silicon providers. So we will probably get the earliest access points and probably devices towards the end of the year. Now, then there's an interesting case of whether we start seeing it in consumer grade products like maybe smartphones first, or the first laptops and other devices on the client side. It wouldn't surprise me if we start to see maybe the first couple of sort of laptop type form factors towards the back of the year. Maybe they're like the more enterprise-focused ones. I have got a one of the first Wi-Fi 6 laptops last year, which was the Microsoft Surface Laptop 3. So maybe if that comes out in the next version, depending on delays in their supply chain. No idea about things like iPhone and Android devices. And to be honest, we may find that new devices are held up more by other supply chain issues, given what's going on around the world, that it might be that they get delayed because of displays rather than the communications chips. So it's very hard to predict at the moment.
Yeah, I may add, Christian, I mean, I would say there's three vectors you really need to keep an eye on this one. One is definitely the FCC, right? They're a critical part of the timing. The good news is we just saw the FCC chairman basically announce the rules on April 1st, right? So that means we're well close to the next major milestone. There is the report and order. So we're all waiting for the report and order to come out of the FCC. The other major milestone is around the chipsets themselves. I participated in one of the Broadcom thing earlier this year. So I think the chipsets are well on their way towards the end of the year. The other critical thing is probably the WFA, right? If you look at the Wi-Fi, one of the greatest things about Wi-Fi is the WFA basically brought interoperability. And Wi-Fi has really become the neutral host of our mobile experience, right? Wherever you go, Wi-Fi is the same. And I think we're looking forward to seeing the WFA bring their first Plug Fest towards the end of the year. And so that's probably the other critical milestone. And that's where we'll start to see who shows up for the Plug Fest, between the AP vendors and the client vendors. So I think, as Dean mentioned, I think the end of the year is kind of where we're starting to get critical mass, where all the stars start to line up for the next major step.
One additional possibility is that rather than ordinary client devices, we might see some early use of the 6 gigahertz band for connections between the access points in meshes, as well as, so it's almost like AP to AP as well as AP to client is a possibility.
And that's going to be interesting to see, because 6 gigahertz, like the penetration through walls and things like that, is going to be lower than what it used to be for 2.4 or 5. So it's almost like it could be a mesh thing. I totally agree, and it would be great for that. But then you almost have to have an AP in every room, or at least every other room, because 6 gigahertz will not penetrate.
So it sounds like it'll enable some of the Microcell designs as well, just with the shorter range.
I think so. Yeah. It will be definitely shorter than 2.4 and a little shorter than 5.
I mean, I think as Dean mentioned, right, it's an interesting band right now because there's a portion of it that looks just like 5 gigahertz DFS radar channel where basically low power devices will not have to coordinate. But there's another part of it where high power devices have the option of doing these databases, right, for coordination. And that kind of opens up a whole new market for this outdoor point-to-point market that we may see evolve.
Yeah. Now, kind of shifting gears a bit here to the economic side of things. I mean, Dean, are you expecting to see this impact applications? Are we going to see a boom in applications? I think myself and I see a lot more people getting into video just in our work mode we're in right now. Is that going to ripple off and drive into this?
Possibly. I mean, clearly, in certain places, video drives a lot of traffic. But to be honest, even with a high-end video conferencing or mid-range that we're all doing using Zoom or WebEx or something, frankly, compared to 4K Netflix on a consumer TV, it's still pretty small. So actually, it's more likely to be the gaming in a residential context. It's streaming and gaming rather than video conferencing. In an enterprise, maybe, but again, there often it's other cloud applications as well. The interesting one for me is actually on the industrial side, and whether we see some of the companies which have, well, they actually can't call them Wi-Fi today. It's like hacked versions of 802.11 or industrial wireless LAN for things like automation and robots in factories or production lines. So whether they start transitioning to this, as a way of giving sufficiently high performance, some level of quality of service management, ideally deterministic low latency, because that's certainly the market that, if you like, on the other side of the wireless industry, the 5G world is looking very much at this whole factory 4.0 thing. So it'll be interesting to see if the industrial wireless LAN guys get there first, if the spectrum becomes available in different places.
Okay. Bob, can you weigh in on, in terms of, I mean, we look back at when Wi-Fi first came out, 2.4 gigahertz, and just the spectrum we had. It was pretty narrow back then, but a lot of business was driven by it. How is it going to impact the economy in the networking space?
Yeah. The interesting thing, right? Since I've been around since the early '80s, and when Wi-Fi started to come out in the late '90s, 2000s, we've gotten to the point now where between the consumer and the enterprise market, there's a pure almost $20 billion market just for us who are selling access points, right? Either to consumers or enterprises. If you look at the WFA, it looks over the last 30 years or so, we've seen about $1 trillion or more of economic impact from these unlicensed rules. I suspect that we're basically doubling the capacity of the unlicensed band, that we'll basically accelerate that $1 trillion ecosystem. Now, where I see new ecosystem falling into it is if you look in the band, between capacity, performance is probably the other thing we're going to see that we haven't seen for a while. Between the 160 bands, really making gigabits per second really viable. And that's really becoming critical because more and more of my buddies, I live up in the hills, so I'm still living off my little 10 megabit link, but more and more homes are getting these gigabit per second connections, right? And so it's slowly up to now, the backhaul has always been the bottleneck in our home. But that's becoming less and less true for more of us. So I think Wi-Fi 6E is really going to release that bottleneck, depending on what you're trying to do, right? And that's all the gaming and video. So that promise of gigabit per second in your home, low latency, is going to enable a whole new set of the industry, right, in terms of applications. So augmented reality, I think we're going to see that start to explode with Wi-Fi 6E. It's going to enable a whole new set of experiences we haven't had to date.
Yeah, low latency. Low latency and low jitter are really what I'm expecting Wi-Fi 6 to give us. Clean spectrum, and what low latency and low jitter essentially give us with a fairly high throughput is finally we can start getting rid of those choppy audio issues, choppy video issues, and things like that, like intermittent Wi-Fi problems. If we have enough channels and we have a clean spectrum, those intermittent Wi-Fi problems that we're seeing left and right with video conferencing, with audio calls, things like that, if we can just resolve roaming with 6 gigahertz Wi-Fi as well, I think the quality of Wi-Fi will be the one of the key driving factors. I totally agree with Bob. It's the bandwidth, but it's also the quality of the connection.
I think there's another one which is in fact all of us are demonstrating at the moment around working from home and the ability to have multiple users in a residential setting in particular, and obviously there's enterprise as well, but from a residential point of view, I think that there's going to be a big push, not just for gigabit broadband, but for sort of almost like a consumer version of SD-WAN, where you can have an enterprise-grade working from home connection and a consumer-grade TV streaming or gaming experience in the same household, either with one fiber or possibly even have two accesses. You might have a fiber and a 5G fixed wireless access to the house, and 2 or 3 or 4 almost like virtualized Wi-Fi networks enabled in the same property. You could maybe have the working from home user on the 6 gigahertz and the gamer on 5 gigahertz, or vice versa. There's all sorts of clever use cases and ways of slicing this up that you can imagine.
Now, Bob, how do you think this is going to impact future-proofing of Wi-Fi? I mean, does it play into the lifespan here, just opening up more spectrum? I know we've trying to squeeze out everything out of the 1024 QAM in the most recent, and really trying to squeeze the most out of the air. How does it impact that?
Yeah, I mean, I think, as I said, if we go forward, right, it is clear there's a couple of trends happening right now. And COVID really emphasized one trend, is that the lines between consumer and employee are blurring, right? when I wake up in the morning, I'm a consumer. A minute later, I'm a worker. So I'm bouncing back before these two environments. So I think what we're going to see is really an evolution of Wi-Fi in this unlicensed spectrum and cellular in our licensed spectrum, right? Because we've become very dependent on cellular as our outdoor experience, right? And I've become very dependent on Wi-Fi as my indoor experience. So I think we're going to start to see those two worlds blurge together. Up to now they've been kind of oil and water. Trying to get a 3GPP guy to talk to an IEEE guy is almost like Middle East warfare, right? You got to basically get those two worlds coming together. So I think we're going to start to see our cellular and our Wi-Fi worlds start to converge together. I think we're going to find out people really just want to make sure they're connected to the internet. Wherever they are, we basically want the best connection we can get. And Wi-Fi 6 is going to be yet one more tool in that toolbox to making sure that, yes, when I want to get connected, whether it's video, audio, conferencing, I really want my phone and laptop to make the best decision it can.
I think I agree, but I think some of that warfare is going to continue, and I think the battle will move to what the cellular guys refer to as the core network, and whether you end up accessing the internet via a 3GPP core network or not. And certainly if you speak to people on the mobile side, they're trying to pitch that idea for all the fixed broadband and say, well, yeah, you can have the brand new 5G core function distributed out to the edge. I think that for a lot of the use cases we're talking about here, that just adds additional friction. But I think that will be the next discussion as well.
Yes, I mean, big boost in terms of throughput here. I mean, is this going to impact, I mean, we talked about the core. Do you think the access network is going to be impacted and how?
I think now, like if you're looking at switching, now's the time to start considering seriously multi-gig switching. Previously, it's multi-gig has been a nice bonus, but rarely have you had the opportunity to really throttle things up enough to get much benefit from it from the Wi-Fi perspective. Now with Wi-Fi 6 and especially 6E truly can push Wi-Fi way beyond that 1 gig limit. So definitely, if I were, starting to look at my switching plans right now, I would definitely look at Wi-Fi 6E and kind of try to understand where that's going to go in the next 5 to 10 years.
Yeah, I mean, I would add, I think it's very similar to what we're seeing in 5G, right? As we see 5G roll out, it's all about moving fiber to the base station, making sure that we have the infrastructure to keep up with the wireless links. I think we're going to see the same thing happen in the enterprise space. As we start to put more capacity and performance into our enterprise spaces, the same thing, you want to make sure the infrastructure is not the bottleneck. And I think we're starting to see that in the home, right? As I mentioned before, I think we're starting to see the wired backhauls becoming less and less the bottleneck. You want to keep a balance between the wired backhaul and the wireless. You want to make sure those are staying on par with each other.
Yeah, I'd love to get a perspective actually from Dean first and then Bob, just in terms of how does this tie into the whole 5G or cellular to Wi-Fi convergence, and is it going to have any impact one way or the other?
I think we're going to see, ironically, I think we'll see both convergence and divergence at the same time. I think by and large, most buildings and enterprises will need very good Wi-Fi and very good cellular throughout their properties, not just indoors, but if a campus type of environments and their sort of outdoor spaces as well. But they may well be used for very different applications and use cases, and they may have different timelines. So, for example, on the cellular side, almost every building, whilst you can use Wi-Fi, it's very difficult to persuade all of your guests all of the time to always use Wi-Fi. So you pretty much will need, if you have a public venue like a hotel or a convention center, you'll need to have decent cellular coverage as well. And you may well find that there are other new use cases for cellular that mean that becomes even more important with, I don't know, IoT. The guy comes in to fix the elevator and he's got an augmented reality headset which has an embedded 5G modem in it. We don't know what's going to happen. So I think that when I speak to people on that side, they will need to have good indoor cellular for coverage of, if you like, the outdoor network inside, so the normal carriers. There's also another move ahead. I'm seeing in a lot of industries where people want to deploy their own private cellular network. So in the US, you've got CBRS spectrum. In Germany, you've got 100 megahertz doing 3.7, 3.8 gig. Similar in UK, Japan, France, a bunch of other markets around the world. And those are going to be used for a variety of use cases, particularly where you've got mobility. So if you've got a robot or what's called an AGV, which like an automated forklift truck, which takes stuff from factory number one, across the outdoor area and drops it off in factory number two, that will probably use cellular, whereas the machines which are actually bolted down in the factories will probably use Wi-Fi or fiber. And then in a public environment, you may well find that you want to have cellular for certain use cases for public use, but Wi-Fi for others. And I think that where possible, they'll get integrated. And I think that actually the integration layer is going to be what you just said about having deep fiber throughout the building, because whether you're feeding Wi-Fi access points, whether you're feeding small cells, or the new brand or new trend towards virtualized RAN for 5G, you will need more fiber to drive it. And so I think that that's probably the convergence layer. Now, as to the software and whether you have it all glued together with the 3GPP core network as a controller for security, maybe not, and I think that's still out there.
Yeah, I guess I would say, Christian, I think we're already seeing the convergence of 5G and Wi-Fi happen. I think at the broadest terms, if you look at the 5G definition now, 5G equals almost all spectrum, right? If you look at, when you talk about 5G, now we're talking about millimeter wave, we're talking about, 1.8, all the cellular bands, and we're also talking about Wi-Fi. So I think if you look at the spectrum level, 5G almost equals all spectrum now. If you kind of move up your stack, you can already see at the RF level, it's really hard to tell the difference between Wi-Fi and cellular at the physical layer, right? OFDM, MIMO, scheduled MAC. The technology itself is starting to converge where everybody's getting to the optimal solution for using spectrum. I think the next level of conversion is really at the user level, right? As I said before, I think we're going to start to see, and we're already seeing it in our phones, right? My phone today, when I make a phone call right now, it already decides whether or not it's going to do Wi-Fi or cellular. Cellular is my first choice. If I make a phone call, it'll make a cellular. If it doesn't, it'll back off to Wi-Fi. And I think that's what we're going to start to see as a practical, LTE cellular was really designed for voice right off the bat. That's its DNA. And it's my first choice if I can get it. If I can get it, LTE, yes, I want cellular for my voice call. Wi-Fi, we're on the Zoom call, right? We're all at home on our Wi-Fi network because this is where video goes, right? When I need capacity, I need spectrum. And so I think that is a convergence where it's happening slowly. I thought it would happen a lot faster. Before I retire, I think it's going to get there. I think we're going to see all our phones start to leverage every piece of spectrum it can to keep us connected to the internet.
And Christian, sorry, just to add, I know there's a lot of wireless engineers listening to this podcast, and about this convergence thing, this also means, and it's already started to happen, that wireless engineers will need to understand different technologies more and more. That's already taken place with, like, Wi-Fi engineers need to understand, for example, Bluetooth Low Energy BLE as well as Zigbee, but now increasingly, like, they're already taking CBRS courses. They're looking at 5G very closely. So life isn't gonna get any less exciting for us Wi-Fi engineers as well.
Well, and then playing on UC, right? I mean, probably the other trend here in the wireless space is the 6 gigahertz band. It also is being used by our ultra wideband friends, right? And so we're kind of seeing two things converge around connectivity, trying to keep us connected. And we're also seeing this kind of indoor location trend emerging, right, inside of our enterprise. So we're kind of seeing connectivity and location have to play nice together now also.
Yeah, that's the other trend for wireless engineers. They, for the last 3 years and increasingly today, they need to be also location tracking engineers, which they have nicely become. So thanks to Bob and your team. So
with this boost in bandwidth too, I mean, are you going to see more shift away from centralized data plane architectures, controllers as well? Do you think it's going to accelerate that, or not really play into it?
Well, I mean, I can wait. I mean, I think we're already seeing, my last startup was a controller startup, but, I think controllers had a nice run for 15, 20 years. I think we're starting to see the architecture become much more distributed, right? And we're seeing that all across the networking thing where we're starting to distribute the data plane. We're starting to see compute storage move closer to the internet exchanges, right? And we're starting to see data trafficking, what I call bumps in the wire, right? We're starting to move all our services into the cloud. So traffic is becoming much more distributed on where that traffic's going, right? Most of our traffic is headed somewhere from our home or our business to some cloud service. So I think, we're going to start to see data flows start become much more distributed depending on where their destination is.
Yeah. All right. So why don't we wrap up just a closing comment from each of you, UC, Dean, and then Bob, just in terms of overall what you think the impact's going to be.
So I'm just gonna summarize the whole because there's still confusion even after this talk about, well, what was Wi-Fi 6 again, what was Wi-Fi 6E and all that stuff. So maybe like what I was thinking when earlier today, like how to summarize. So Wi-Fi 6 is new Wi-Fi, old spectrum, and Wi-Fi 6E is new Wi-Fi, new spectrum. That's if you remember one thing out of the whole thing, that's it.
So from my point of view, I think that this is a really important milestone in terms of continuing Wi-Fi's central role in the enterprise offices and in the home by adding additional, not just additional spectrum, but spectrum which is going to not be backward compatible. It will just have Wi-Fi 6 in it. So all of the ability to differentiate based on quality of service should be much easier to achieve with the new implementations. And also from a timing point of view, it looks to me as if the end of the year is a really critical point. And I think that the interesting thing for me is that everyone's trying to go after 6 gigahertz, as well as Wi-Fi. The cellular community will try to do unlicensed, like a equivalent of LTE-U, so 5G-U or something like that. But I suspect that given all that's going on at the moment, they're going to be a bit later than the Wi-Fi industry at using 6 gigahertz, which sort of tilts the future landscape. So I think it's going to be quite interesting to see what the relative speeds to market are.
Yeah, I'd say from my perspective, Christian, I think for me, when I look at Wi-Fi 6E and the 6 gigahertz band, it really kind of unlocks all the technological improvements that have happened over the last 15, 20 years with Wi-Fi, right? And a lot of those improvements are really limited in the 5 gig band because we never were really able to really leverage everything that happened, either between not having enough 160 megahertz channels or having to limit ourselves by dealing with legacy customers. So for me, what's exciting is the 6 gig band is really going to unlock the full potential of all the Wi-Fi development that's happened. We'll be able to leverage all these channels and all the technology we've been developing for 20 years, and we won't have to be able to deal with legacy 2.4 clients from 20 years ago. And this is really going to enable kind of the next big wave of applications and use cases that we really haven't seen probably since the early days of Wi-Fi.
All right. Thanks a lot, everybody, for joining. And if you do want to learn more, we have a technology resource page at mist.com/y-fi-6e. And I'll just keep updating that with external resources like this and blogs and industry news. So thanks again for joining. Have a great day.